Hello and welcome to our tutorial series about line differential protection. Line differential protection is a core element of line protection and is applied from transmission down to distribution voltage levels. Our tutorial series should give you an introduction and deep insights into line differential protection theory and the Cipotec 5 line protection devices. This session is about Cipotec 4 and Cipotec 5 compatibility. By this I mean the question, can you combine a Cipotec 4 device and a Cipotec 5 device in a line protection topology, and what do I have to consider? If you are already joined one of our last energy automation webinars, you already know the Q&A field on the upper right side in this application. Please enter your questions there. We collect them and answer them in a live Q&A session for those who attended the tutorial series. My name is Nina Hühn and I'm technical expert for differential protection. Okay, now let us start. This session consists of two parts. The first part is about the theory, so questions like, what are the hardware requirements? Which firmware version do I need? And what are the restrictions? Second part is a demo in Dixie 5 and Dixie 4. Our Cipotec 5 devices can work together with Cipotec 4 devices in a line differential protection scheme, but can also cooperate with Cipotec 4 distance protection devices. We start with the use case distance protection. For distance protection applications, we only need to exchange binary signals for teleprotection schemes, like an echo signal, the information about the faulted phase or the fault direction. We typically only have a setup of 2 to 3 devices. The transmitted data payload is small, and the device synchronization is not needed. Let's compare this with the use case line differential protection. Here we exchange synchronized measured values plus binary information. Protection schemes with up to 6 devices are possible. Since we are not only transmitting binary information, the data payload is high. To make the currents from all ends comparable, we need an accurate synchronization for the measured values. Let's talk about the supported functionality. We start again with the use case distance protection. When it comes to teleprotection and the exchange of binary signal, Cipotec 5 offers more functionalities and flexibility than Cipotec 4. When the two device families are working together, the scope of cooperation is of course limited by the signaling procedures available in the Cipotec 4 devices. Supported functionalities are the transmission of additional user-defined signals, constellation method values, and the functional lockout of the device. For the line differential protection, the supported functionalities are the sensitive stage IDIF and the stage IDIF fast. The stage IDIF fast 2, available in our Cipotec 5 modular devices, is not supported. Also for line differential protection, constellation measured values and the functional logout of a device are supported. It is also possible to additionally exchange binary information, like remote indication commands or any other user-defined signal. In the next 2 slides, I want to talk about typical use cases for the compatibility mode. First example on this slide is that you want to extend your existing Cipotec 4 topology with a new Cipotec 5 device. And then, sometime later, you need to replace your device in substation A and use also a new Cipotec 5 device. So, you have the full flexibility. On this slide is an example where the customer has 4 stations equipped with Cipotec 4, and now station 1 is being renewed and equipped with Cipotec 5. So here the compatibility mode is necessary. if there's more than one CBOTEC 5 device in the topology, a CBOTEC 5 device within the topology must run in the compatibility mode. And all devices, of course, also must fulfill the requirement for the compatibility mode. All the information in this presentation is also included in our CBOTEC 5 line protection device manuals. We have a comprehensive chapter for the topic cooperation with CBOTEC 4 devices. The next 3 slides are about the question which communication link for which distance is applicable with the compatibility mode. We start with the communication topologies where you have a short distance module on CBOTEC 4 side. For the use cases on the slide, no changes are necessary. Here you simply can exchange a CBOTEC 4 with a CBOTEC 5 device. No further equipment is necessary. For a short distance, up to 2.5 kilometers, a direct fiber optic connection between the 2 devices is possible. For this setup, you need a FO5 module in the CBOTEC 4 device and then a USART 81 or AE2 FO module on the CBOTEC 5 side. If you already have a communication topology for a distance greater than 100 km with 2 repeaters, you can exchange your CBOTEC 4 device with a CBOTEC 5 device with a USART 81 or AE2 module in it. The same is valid when you have a communication topology with communication converters in it. Here, all media between the 2 converters that worked for your CBOTEC 4 setup will also work for the CBOTEC 5 devices. For example, pilot wire connection. Okay, let's talk about the use cases where you have a long distance module on the CBOTEC 4 side. Here, additional equipment is necessary. The sketch on the upper half of the slide shows the existing communication topology for a distance up to 100 km with 2 long distance modules, FO17, 18 or 19. If you want to replace one of the 2 CBOTEC 4 devices with a CBOTEC 5 device, you need 1 repeater on the CBOTEC 5 side. The required modules in the CBOTEC 5 device are USART 81 or AE2 FO. The reason this additional repeater is needed is that the long-distance modules of the 2 device families are not compatible. Since firmware version 9.30, it is possible to establish a direct optical connection to a multiplexer with a C37.94 interface. The required hardware on CBOTEC 4 side is a F30 module. On CBOTEC 5 side, a USART 81 or AE2 FO module. The required firmware version on CBOTEC 5 side is a 9.30. With this slide, I want to summarize the hardware requirements for the different distances. For a short distance, smaller than 2.5 kilometers, a direct connection is possible. On the CBOTEC 4 side, you need a FO5 module. On the CBOTEC 5 side, a USART 81 or AE2 FO module. For distances greater 2.5 km and smaller 100 km, you can use on the CBOTEC 4 side a long distance module FO17, 18 or 19, and on the CBOTEC 5 side a USART 81 or AE2 FO module plus a repeater type 7XV5461. For distances greater 100 km, you need a repeater type 7XV5461 on both sides, and accordingly a FO5 module on CBOTEC 4 side for the connection to the repeater. Until now we talked a lot about hardware requirement, but what's about software requirements? For the combination of 2 distance protection devices, you need a firmware 4.70 or higher on CBOTEC 4 side and a firmware 7.90 or higher on CBOTEC 5 side. A firmware version 9.30 is necessary for the IEEE C37.94 communication topology. For line differential protection application, you need at least firmware version 4.72 on the CPROTEC 4 side, and again a firmware 7.90 or higher on the CPROTEC 5 side, or 9.30 for the C37.94. This slide shows a compatibility matrix. In my opinion, it looks more complicated than it is. The rules are pretty simple. You can combine the CPROTEC 4 line differential protection devices 7SD with all CPROTEC 5 devices with the capability of being part of a line differential protection scheme, such as all 7SD devices, the 7SL devices, but also the 7UT, or of course our universal device 7SX. Hereby is the 7SD61 only for two end-line topologies. All CPROTEC 4 distance protection relays, the 7SA devices, can be combined with all CPROTEC 5 devices that have a distance protection function, such as all 7SA devices, the 7SL devices, the 7UT, and the 7SX. We already talked a lot about requirements and use cases. Now I want to give you an important hint about the settings. CPROTEC 4 and CPROTEC 5 devices differ in the hardware and software used for measured value acquisition. When using the line differential protection within a device family, for example CPROTEC 4, certain inaccuracies of the measured value acquisition are automatically compensated. If the line differential protection is operating in a device combination with CPROTEC 4 and CPROTEC 5 devices, greater inaccuracies occur in the measured value acquisition. This means that a differential current is calculated which is not actually there. You must compensate this increased error in the differential current using increased stabilization. In the CPROTEC 4, CPROTEC 5 operation mode, Siemens recommends other setting values for the parameters of the current transformer errors. The following table shows the new recommended settings. The two columns on the right side of the slide are, in quotes, normal values for comparison. The remote data in CPROTEC 5 corresponds to the remote commands in CPROTEC 4. The remote commands and remote indications are specified in CPROTEC 4 with regard to quantity and type. In CPROTEC 4, 4 remote commands of the type SPS and 24 remote indications of the type SPS are supported. The bit position and the priority are already defined in CPROTEC 4. There's also pre-assigned information such as the inter-on signal or the manual close signal in CPROTEC 4 that can be used for the information exchange under the specific bit position. In principle, CPROTEC 5 offers significantly more flexibility here. But when the devices are working together, it is important to pay attention to the functional scope of the CPROTEC 4 device. Yeah, what brings me to my last slide of the series, part of this session. I want to talk about restrictions. Hereby I mean the question, what functionalities are not or not yet supported? The first point is the two-ended fault locator. Both device families offer this functionality, but they are not compatible. Available only in CPROTEC 5, and as a consequence, therefore not available in the CPROTEC 5-CPROTEC 4 combination, are the following points. Differential current supervision, the extended frequency range of plus minus 10%, 5% more than CPROTEC 4, the improved IDIF fast stage, IDIF fast 2, the IN, and the I2 negative sequence differential protection stages. Only available in CPROTEC 4 is the detection of a simultaneous wire break on all three phases. In combination with CPROTEC 5, only the detection of a wire break in one phase is supported. Okay, enough about the theory. I will now give you some hints about the configuration in DIXI 4 and DIXI 5. So we come to the DIXI 5 live demo. For this, I prepared already a DIXI 5 project and created a 7ST86 device. For the device creation, I used the template for line differential protection schemes. So here we already have measuring points, voltage and currents. We have our function group lines with a lot of functionality in it. We have a function group circuit breaker. Also, I newly inserted the protection communication with one protection interface and the function block device combination. So here I used for this configuration, I used the new workflow for the advanced protection communication. But everything I will say in the next minutes is also valid for the classic protection interface. Here I don't want to go too much into the details of how to configure the devices. I simply want to give you some hints or point out on which positions you have to make sure that the settings are the same as on the ZProtect 4 side, that everything will run smoothly together. So first thing is I go to device information and will check the version of the device. I said for the device combination we need at least firmware version 7.90. In this case we have a configuration version of 9.60, so way newer version, so this is already quite fine. And if you want to check the firmware of the device, you can do a right mouse click on the device and use the dialog load firmware to the device. And then you can read here the current firmware version. This is empty at the moment since this is only an offline configuration not connected to an online device. But if you are online, you can check, okay, which version has my device, or you check it via the device HMI. Okay, next step is I want to go to my function group protection communication, and here I start with the function block device combination. Here, more or less, the most important setting for this compatibility mode is under the tab General, and here the setting for the connection mode. Because here you can make this decision, okay, this device is within a topology with another ZProtect 5 device, or within the topology with a ZProtect 4 device. And here you have the selection options, ZProtect 4 7SD61, 7SD5 or 7SA56. So the last one would be, of course, a combination for the distance protection devices. Okay, for our example, I will choose the option 7SD5. This is for a more end line differential topology. Also under this tab General, you see the setting, okay, which one is my local device. This must be, of course, fit. So here you should not see the same values in ZProtect 4 and ZProtect 5. The setting lowest appearing bit rate is a setting that is only available in ZProtect 5. So whatever you set here is not relevant for the ZProtect 4, ZProtect 5 compatibility mode. Settings that are available in both devices, ZProtect 4 and ZProtect 5, are of course the addresses of the device. So which device has which address. These must be, of course, the same in both devices. Okay. Then I want to go to hardware and protocols. And here go to the settings of my module. In this case, I have a user.ad one FO module. This would be a module either for a direct fiber optic connection for a short distance, or when you have like a connection and a repeater in between the Zipotec 5 and the Zipotec 4 device. The protocol I selected is the advanced protection interface, but of course it would also work if you choose the classic protection interface. The setting here, this is also of course important that it fits to your real configuration, that you decide, okay, is it a direct connection or are we connected somehow to a repeater or something else. Okay. Next step is I want to go to the settings of my function group line. And here I start with the tab General. Here we see the rated values and the line data. These values should be set to the same values in Zipotec 5 and Zipotec 4. Most important one maybe here is the rated current. This rated current must be equal in both devices. If not, the communication will not establish. Only exception is when there is a transformer within the zone, then the rated parent power must be equal in both devices. Okay. Then, I want to go to my device settings here. Here under 7ST86 device settings, I want to point out that the rated frequency should be the same in both devices, or in all devices in the device combination. Then I want to jump to the settings of my 87 line differential protection. Here the Zipotec 4 and the Zipotec 5 settings, they are equal. Sometimes the naming is different, but they mean the same. So here, make sure that they are the same, that the threshold values are the same, that the operate delay is the same, so that these settings fit with each other. One important thing is the IDIF fast stage. When you create a new project in Dixie 5, per default, there will be the IDIF fast 2 stage available. The IDIF fast 2 stage is our new improved IDIF fast stage, and it has like an improved saturation detection in it. But the IDIF fast 2 stage is only available in Zipotec 5 modular devices. So when we are talking about Zipotec 4, Zipotec 5 compatibility, then it is important that you delete this IDIF fast 2 stage and add a new stage and insert this new stage to your project, like it is done here. And then, this IDIF fast stage is also available in Zipotec 4, and you can make the same settings for the stage. Okay. Additionally, allowed stages in the compatibility mode are the transformer. So this would be like an additional feature when you have a transformer within the zone. This is also working for Zipotec 4, Zipotec 5 compatibility mode. And the charging current compensation. When you have it in one device, make sure that you activate it also in the other device. All the other stages that you see here, the IDIF fast 2 stage, the IN diff stage, and the I2 diff stage, are not available in Zipotec 4 and therefore must be deleted or not even inserted in Zipotec 5. Okay. Then we can take a look at the settings of the CTs. So I open the settings of my measuring point current. Here is the current transformer ratio. This must not be equal on both cases, on both sides. So it is no problem to have different CT ratios on both sides. The only rule is that the CTs on both sides must fulfill the CT requirements. Also, the CT class on both sides can be different, but yeah, I already mentioned this table where you see the new recommended settings for the CT arrows. This table needs to be considered. And these settings are made here. So in the measuring point current under CT phases, you see the CT arrow changeover point, CT arrow A and CT arrow B. And here we need slightly bigger values than when you are sticking within one device family, I would say. So these values must be increased. And of course, if you have different CT classes on a different site, make sure that they fit, so that you choose the right settings according to the table. This table can also, of course, be found in our device manual. Okay. When we're talking about CT ratio, maybe it's also worth to mention under device setting, you can define if your edit mode is secondary, primary, percentage. Here, make sure that when you are configuring it in ZBOTEC 5, that this is the same value than you ZBOTEC 4, so that you don't get confused during the configuration. Okay. So next step, I go again to the 87 line protection. We already talked about most of the settings, but I missed one important thing, and this is the so-called IDIF supervision. This functionality is only available in ZBOTEC 5, and therefore not available in the compatibility mode. So here for supervision IDIF fast, within the settings of the 87 line differential, switch it to no. Okay. Also, settings for remote trip must be the same on both sides. All right, that's all for the ZBOTEC 5 that I want to show you. Maybe just let me repeat the two most important things here. Please make sure that under device combination, you select for connection mode the ZBOTEC 4 device, whatever it is. And under measuring point current, that you consider the higher CT arrow values. Okay, so much about DIXI 5. Now I want to jump to DIXI 4. Here I also already created a project, a 7ST52 device. You can take a look at the object properties. It has a line differential protection function in it. The communication module that is configured here is for a 60 kilometer distance, so a long distance module. This, for example, would be would be an example for where you have the long distance module on ZBOTEC 4 side and the repeater on ZBOTEC 5 side. This is also possible. So for ZBOTEC 4, we said we need at least firmware version 4.72 for line differential protection. In this example, we have a parameter set version of 4.76, so a newer one. And you can also check the firmware version on your device HMI if it is new enough. Okay, then let's open this device. And again, here I don't want to talk about doing the whole configuration. I just want to mention the most important points, what settings must be equal when working in compatibility mode. So first thing is I open the settings and go to Power System Data 1. And here under Power System, you see the rated frequency. This should be the same in all devices in your device combination or topology. Then here also under Power System Data 1, you see the values for CT arrows. Of course, also on Sybotech 4 side, these values must be changed to the slightly higher values that we recommend. And this is actually the only change that you need to make on Sybotech 4 side. So you don't have to change anything in your Sybotech 4 configuration if you don't want to, but the CT arrow is the one thing that you must change. Here the values must be bigger than when staying within one device family. Okay. Then I go to setting group A. And here under Power System Data 1, you see the so-called full-scale current. This is equal to the nominal current in Sybotech 5. And of course, here also we need the same value on both sides for the communication to establish. Also, yeah, this is important. All right, then we can also take a look at the settings of the differential protection. But here you see these are the same. The threshold values are also available in Sybotech 4. Here this recommendation is simply set it to the same values as on the Sybotech 5 side. So last thing is we can go to the settings of the protection interface. So here I go to protection interface. Here you see like the setting for your interface 1. How is the connection be done? So direct or over converter or over repeater. Of course, this setting must fit to your real physical setup. And yeah, all these settings that you see here for the protection interface or that you see here under the tab General must simply be equal or should be set equal as to Sybotech 5. Okay. Last thing here, in setting group A, under differential topology, you see the addresses of the device and you define, okay, which one is my local device. Here, of course, the addresses must be the same. The local device should be different. So if you have two devices, one device should be device number 1, second device should be device number 2. And yeah, that's already everything that you need to consider in Sybotech 4. So typically, you can leave your Sybotech 4 setup untouched. The only thing that you need to change are the CT arrow settings. And everything else can stay as is. And just make sure that then on the Sybotech 5 side, you will configure it in the same way as in Sybotech 4. And yeah, then I'm already finished with this session. I hope you enjoyed it. Thanks for your attention, and we would be lucky to see you again in one of our other sessions. Have a nice day.